Having completed the last lecture, you have a good understanding of what BLE is and how it works with the Arduino 101. In this lecture, I would like to show you how you can implement an application based on one of the standardized BLE profiles, the heart rate profile. This is the same profile that commercial heart rate monitors use. Using the same principles, you'll be able to create applications by implementing any of the BLE standard profiles, ensuring compatibility with any other device that supports it. Let's get into it. In this example, I'd like to play around with an official BLE specification and characteristic, that is the heartRateService. The sketch I'll be using is this one here. In the beginning, I create the peripheral and then I declare the heartRateService, and the UUID that I use for this service is 180D. 180D is an actual official BLE service, and if we have a look at the developer bluetooth.org website, you'll see that if I search for 180D down here, that's the specification for the heart rate service. I'll drill into it. So the UUID is the one that I used in my sketch. Now, by using this UUID, devices that are compatible with this heart rate specification will be able to connect to it. That's because of the ID that is standardized. So if I go inside the heart rate specification, I'll find out more information about it, and especially the characteristics that are part of this specification. So here we can see that we've got the heart rate measurement characteristic. It's a mandatory specification, so it must be included with any service that implements the heart rate BLE service. There's also the body sensor location. So this tells the connected device where the sensor is located, and the heart rate control service, but these two are not mandatory. So our sketch implements the heart rate measurement characteristic. If we go back to it, you'll see that at BLE characteristic, we create the heart rate characteristic, and the ID for that is 2A37. It implements BLERead and BLENotify, and those are 2 bytes long. So let's check this out. We've got the 2A37 UUID for the heart rate characteristic, and if we drill into that, we'll find out that this is the assigned number, the UUID for the heart rate measurement, and these are their specifications. So 8-bit, information about what each one of these bits does in the flag. So this is the flag part, and then we also have another 8 bits for the heart measurement value. Okay, so that's a little bit of background, just to give you an idea of what the BLE specifications are like and what these UUIDs really mean. So you can use standardized UUIDs if you want your gadgets to be interoperable or able to communicate with other devices that are also implementing the standard BLE services and characteristics. On my circuit side, I've got the Arduino 101. I've connected an LED to digital pin 13 and the potentiometer that reads a value at analog pin 0. I'll upload the sketch. Upload the sketch. The idea here is that as I'm turning the potentiometer, the simulated heartbeat value will be sent to a connected BLE device. Okay, so Bluetooth device active and waiting for a connection. You can see that automatically the app on my phone detected that there is a heart rate sketch nearby. That's a service offered by an Arduino 101. And the heart rate sketch is the local name that is being advertised as set in the sketch. So I'll connect to it. And there is one primary service that is offered. And this service allows for input and for output. Right now the value is at 19. Let's change it. I'm just going to turn the knob of the potentiometer while we can look at any changes in the values that are displayed by the app. So let's turn it and get an updated value, 0. Turn it. .21. So this is a hexadecimal 21, and you can see how the sketch updates the reading from the potentiometer. Let's move it all the way to the other side. So there you go. Make it 78 decimal, 77 decimal, and that is 4D in hexadecimal. You can see that we've got 2 bytes that are transmitted. So you could build a heart rate app that communicates with something like a fitness application on the phone that simulates you exercising really hard. So that's at 100, the maximum that the application will allow, and that's hexadecimal 64. And of course the LED should have been on. I just plugged it the wrong way. And when I connect to it, the LED turns on to indicate that there is a connection. Okay, I'll just disconnect and the LED goes off. So I hope that with these 2 lectures you have a good idea of how you can play around with the BLE and the kind of applications that you can build. Let's move on to the next lecture, where I'll show you some aspects of the built-in gyro and accelerometer.